All right, math study students, we're going to talk about 21B, stationary points. So before we even get started, what did we learn about the last lesson when the derivative was positive and when the derivative was negative? And what we learned last lesson was if the derivative is positive, the line is going up. We have a positive slope. And if the derivative is negative, my line is going down, and we have a negative slope. So now we're going to go a little bit further with this. Okay, we're going to talk about something called stationary points. Now, let's think about that. So a stationary point, by definition, is when the derivative is equal to 0. Now, if the derivative is equal to 0, it's neither going up nor down. So at this particular point, for example, it's neither going up nor down. And whenever you have the stationary point, when the derivative is 0, you're going to have something called maximums or minimums or inflection points. I'm going to talk about that in a second. So in this example here, I have the derivative is positive, it's going up. And then at this point, the derivative is negative, going down. Whenever you go from a positive slope to a negative slope, you're going to have something called a local max. Now, if I'm going down and then I'm going up, at that point, we're going to have something called a local min. And then the definition of a global max is the highest point of the graph is a global max. The lowest point here is a global min. So let's think about in the United States. Where is the global min in the United States? Well, Death Valley is the lowest point in the United States. In the United States, what is the global max? Mount Whitney is the highest mountain in the U.S., and that is called a global max. Okay? Now, Mount Diablo is a maximum, but it's a local maximum to the Bay Area. The global max for the United States would be Mount Whitney. That's my example for local and global. Okay, now a horizontal inflection point or stationary inflection point is a different situation when the derivative is 0. Let's look at the example when I have the function f of x equals x cubed. That graph looks like this. I'm sure you've seen it before. Now if I take the derivative of that, the 3 comes to the front, the power decreases by 1, I've got 3x squared when x equals 0. Now for this equation, if I plug in negative values, 3 times a negative, that's going to give me positive. We're going to have a positive slope. And then if I plug in positive numbers, I'm going to get a positive slope. So here, it's positive slope and positive slope, but at this one point, we've got a stationary point, and this has a special name called a horizontal inflection point. Okay, so now we're going to talk about how sign diagrams are useful when we're talking about local maximums, mins, and stationary points. Okay, so if I've got this situation where the slope is going up, then the slope is going down, we've got a local maximum there. In the sign diagram, I would put plus and then minus, indicating the value of the derivative. If I've got a negative slope and then a positive slope, the value of the derivative is going to be negative, and then it goes to positive, and at 1, the value is 0. And then here at 3, it goes from positive, we have a positive slope, the derivative is positive, and then the derivative is positive again, so that there we have a horizontal inflection point. Okay. So, what we just learned. We've got a local maximum when we have a top of a hill. The slope is going up, then the slope is going down. We have a local minimum when we're at the bottom of a valley. The slope is going down, then the slope goes up. And we have a horizontal inflection point when the slope is positive and positive, going up, then it's stationary, and then going up. We also have the same situation When the slope is going down, then the slope is 0, and then the slope is going down. So these are two examples of horizontal inflection points. Okay. Now let's look at this example here, and I ask you to find all the stationary points. F of x equals x cubed minus 3x squared minus 9x plus 5. So in this example, first thing we're going to do is find the derivative. Okay, 3 comes to the front, power decreases by 1. 2 comes to the front, multiplied by 3, power decreases by 1. This decreases by 1, we have x to the 0, so we're just going to have minus 9. And then I see, oh my gosh, it's all, I can factor out a 3, right? So then we get something like this. Okay, and then you say to yourself, oh, I know how to factor this. What two things multiply to give me 3 and subtract to give me 2? Well, it's going to be 3 and a 1. And since this is a negative 3, we know these have to have opposite signs. And to get negative 2, the negative 3 is going to have to be negative. All right, so if I'm going to make a sign diagram, we know that it's 0 when x equals negative 1 and when x equals 3. Okay, so to make a sign diagram, we know it's going to be 0 at negative 1, and we know it's going to be 0 when x is 3. So if I plug in a number that's less than negative 1, for example, negative 2. If I plug in negative 2, I've got negative 2 squared minus 2 times negative 2. Here's my function, right? And then minus 3. Okay. Well, negative 2 times negative 2 is 4. And then negative 2 times negative 2, that's 4. And then minus 3. 4 plus 3. Who cares what the number is? We just want to know if it's positive and negative, and so it's positive. Okay. Now, what if I plug in a number between negative 3, negative 1, and 3? Let's plug in 0. That's between here and here, somewhere. Okay, so if I take this equation here, f of 0, we've got 3 times 0 squared minus 2 times 0 minus 3. I try to pick easy numbers, right? Well, 0 squared is 0, minus 0 times negative 3. So we have 3 times negative 3, which is going to give me, guess what, a positive or a negative number? Negative number. So between negative 1 and 3, we've got negative values. And then at 3, let's pick a number greater than 3. Let's pick an easy number. How about 4? Okay, so if I do f of 4, we've got 3 times 4 squared minus 2 times 4 minus 3. All right, so 4 squared is 16 minus 8 minus 3. Well, we know that 16 minus 8 minus 3 is going to give me a number that's greater than 0, right? So we know this is going to be positive. Okay, so if we want to find the stationary points, here we go. And if we're going to classify the stationary points, then we know if I'm going from positive to negative, at this one here, we've got a local max. And if I'm going from negative to positive, I've got a local min. Okay, so your homework tonight is 21B, numbers 1 and 2, and then number 5, A through F. Good luck with your homework. Email me if you got questions. The first thing I'm going to do is I'm going to take the derivative. Okay, and so if I take the derivative, I get 3x squared minus 6x minus 9. Okay? Then, we want to try to find out when this is equal to 0. Okay? So, this is going to be equal to 0 when, well, first of all, okay, we want this, we notice, okay, everything's divisible by 3. Let's factor out the 3. X squared minus 2x minus 3. And then I think to myself, thinking back to my algebra days, I think, oh, I know when this is equal to 0. Let's factor it out. And then I go x and x. What two things multiply to give me 3? A 1 and a 3. And they both have to have opposite signs. And since this is minus 2, I'm going to write minus 3 and plus 1. Right? Okay. Talk to your Algebra 1 teacher if you have trouble with this. Okay, now, okay, so when is x equal to 0? When x equals negative 1 and when x equals positive 3. All right, so now let's do a sign diagram. Negative 1, 3. Okay, if I plug in numbers less than negative 1, okay, let's just do that right now. Okay, what's smaller than negative 1? How about negative 2? Okay, so if I plug in negative 2 into this function, then I'm going to have 3 times negative 2 squared minus 2 times negative 2 minus 3. Okay. Negative 2 squared is 4. Negative 2 times negative 2 is going to give me positive 4 and minus 3. Okay, we don't even need to multiply the 3 here to figure out 4 minus 4 is 0, and then minus 3 is going to give me a negative number, isn't it? So if I'm doing a sign diagram, let's see, did I make a mistake?